landlines. If if we still had landlines, the level of penetration in terms of telephony would not be the same. Mobile phones have caused a disruption in the communication space. And the disruption has not just been in communications, even this disrupted the camera business, they disrupted the GPS business, and it's going to take those kinds of disruptive technologies to accelerate our development and bridging the gap. The focus is on applied science benefiting society. There's no point in just doing science for science sake. I believe it's got to benefit society. And like my area is water, waste, energy, environment, and food, the nexus. And environmental management, mostly urban water. But the blue infrastructure I call smart urban infrastructure. But there's going to also be eco-sensitive technologies. And this age, really, we're in the age, some talk about the fourth industrial revolution and stuff like that. It's all about knowledge information systems. And part of my talk, now we are seeing the effect of artificial intelligence in terms of things like chat GPS and so on, GIS, big data. My talk will focus on an area called computational fluid dynamics, which is a very powerful tool that's allowing for product development cycles to be accelerated. And I'll show some examples of that in the talk. Individual responsibilities and collective responsibilities. For me, what is the use of knowledge and technological know-how if it cannot be translated into practical applications that benefit society and the environment? I firmly believe that we all have a deep-seated conviction that we are brother's keeper. We should be dedicated to providing engineers, planners, entrepreneurs, health professionals, teachers, students, etc., with the opportunity to contribute to the building of a better world. And I've had experiences in terms of I did my first 20 years in Ghana, did my first degree in Ghana, went to the UK to do my master's and PhD, and did a stint in the UK for about 20 years or so. I transitioned to the US. And the next phase, I've had experiences in, say, the developed world. Next phase, really, my personal challenge and focus is how do I help to contribute to Africa's development? And that's what some of these things are going to be all about. In 2050, water could well be the new oil and ecosystem services the currency. And the question that I have that keeps passing through my mind's eyes, through innovative approaches, can the developing world leapfrog the conventional developmental cycle? Because the gap is so huge. Currently, there's a huge economic and technological gap. And I believe that it's only going to be through innovation that we're going to be able to leapfrog this conventional developmental cycle. Now, when you take the World Bank quote from Ivo, he says, as we all know, urbanization is one of the defining trends of this century. Today, cities are home to more than half of the world's populations. Currently, the cities are adding 1.4 million people per week and generating more than 80% of global GDP. So urbanization is the trend, it's a global trend. And although it's the least urbanized continent today, Africa will soon surpass Asia as the fastest urbanizing region, leading the world in urban growth in the near future. It presents a huge challenge. We take Greater Accra as a region, for example, it's no exception. The capital of Ghana is currently estimated to be home to over 4 million people, projected to house over 10 million by 2040. The region constitutes 25% of the nation's GDP as an economic hub in the West Africa sub-region. I have this quote that our development in Africa is placing unprecedented stresses on ecosystems, which ultimately will challenge our very survival as a species. What do I mean by that, or why do I say this? When you look at satellite images from Google Earth and so on and so forth, you go back to 1930s and you come to present time, this is around 2016. You can see the impacts of rapid urbanization. You can see the effects of desertification, deforestation, coastal erosion, climate change. These are all impacting us on the continent. Our rainforests are being, we're doing deforestation on a massive scale with things like galamsey and so on and so forth. Within a generation, you take these two satellites pictures You can see the extent of urban sprawl. You look around the Greater Accra, the extent of Greater Accra has, is reaching almost to, the uh, lake region. And you look at Takoradi and places like that. You look at the coastal line, you can see the hue, the brown plume that's evident in the coastline. I'm sure that if you go fast forward to 2024, you might see even worse than what we saw in 2016. And the impact is actually visible from space. So I looked at 1984, which is the one on the left, and you can see Takoradi on the left bottom corner. Takoradi has expanded since 2016. But more importantly, when you look on the landscape, you can see the outline of the Pra River as a brown outline all the way to the sea, and you can see the discharge from the Pra to the sea causing a brown plume. And this situation now, this is 2016, it's probably worse now with all the rivers in the southwestern region, the Akobra and so on and so forth. And this is a very serious thing that we as a country need to take serious steps to address. Again, looking from space, you can take this is Nigeria actually, and it's a similar situation in Ghana. You have drains, our test our urban infrastructure. We have drains that are full of water in dry weather. These are supposed to be storm drains. If they are full in dry weather, then when it comes to storm runoff when it rains, are they going to be able to function effectively? Again, drains that are full of sediment and trash, is it going to function as a drain when it rains? And then more importantly, as I followed these drains from the satellite view, I came across a dead end. So you have drains that are going nowhere. And then you have people in these slum areas or shanty developments, poor people there. The drain goes nowhere. So when it rains, obviously all the water is going to inundate their development. So we have major infrastructure challenges. And I believe that we have a major challenge in terms of Ghana's development. Flooding is one of them. And in addition to inadequate infrastructure-related service provision, there are major public health implications. The last issue that we had in terms of the COVID was an airborne disease. But if we had some kind of waterborne outbreak, that could be really devastating. We have this issue with polluted waterways and beaches. This does not bode well for tourism in terms of, no tourists be happy to, pitch camp on a beach like this. So we have major challenges. We will need to move beyond what I call the conventional.
The firepower between the two forces in sections of that front line, when our teams have gone out to...
For example, we will have to address water and sanitation management in an integrated, holistic manner, taking into consideration all the facets of what I call the water cycle, including stormwater drainage, wastewater treatment, and also solid waste management. So it's a multidimensional issue that we are having to face. And in terms of our underdeveloped infrastructure, sub-Saharan Africa infrastructure development lags significantly behind other developing regions. And this results in fragmented related service provision, very limited access to services for our largely urban slum population. And to me, the greatest threat to development lies in what I call the underdeveloped urban water management infrastructure. Why do I say this? There are lessons from the past. If you look at UK in the 1665 to 1660, they had the last major outbreak of the bubonic plague in Britain. It killed nearly a quarter of London's population. Now imagine the impact of an outbreak that kills a quarter of Accra's population. Just imagine that. Accra currently has about 4 million people. So a quarter would be close to 1 million people. So if you had a case whereby you had, a water borne vector as the mechanism for infection, you could easily have a situation where you have an outbreak that's not too dissimilar to the bubonic plague, causing major catastrophe. In addition to inadequate infrastructure, we have the lowest productivity of any region in the world, and this is largely attributed to serious infrastructural shortcomings across several sectors: energy, water, sanitation, transportation, communications, technology. And it's estimated that our infrastructure deficit limits our regional integration initiatives, raises transaction costs for business, and limits growth, estimated to shape of at least 2% of Africa's annual growth. 2% of our growth is massive when you look at Africa's GDP as a whole. The other issue that we face as a challenge, there's a study done by a leading British government institute. And the study indicates that we have what we call low engineering capacity. And the low engineering capacity in sub-Saharan Africa is more accurately described as an inadequate number of engineers with sufficient skills and experience. It's not an insufficient number of engineers per se, where our investors are churning out lots and lots of engineers, but they don't have sufficient skills and experience to actually address the challenges that we face. We have major projects that are being done by overseas contractors and consultants, and that needs to change. And in my view, the main reason why is that our engineering courses in sub-Saharan Africa are often too theoretical, and they're often based on outdated curricula and not relevant to local needs. And I'll come back to this issue when I talk about my own personal experiences. And Africa is a continent of contrast. I firmly believe that with improved know-how and more equitable distribution of wealth and true care for our fellow man, I believe we can address the infrastructural deficits, including the water, sanitation, and environmental challenges faced. March 2007, Ghana celebrated 50 years of independence. So 50 years on, if I now you can say 67 years on, we continue to have major developmental challenges. How do we address these? 21st century challenge, urbanization, the African challenge. Are we going to break the cycle of the evolution of conventional systems and leverage innovations in technology? This is the question I have for us. Because in the Western world, they started with open channels, like we have open gutters, and then they ended up covering them. That's how the sewage system was formed. In our case, the challenge is even more in terms of magnitude, because in addition to, wastewater, we have a lot of solid waste in our urban water infrastructure. So it's a multidimensional issue that we're gonna have to deal with. And the other challenge we have in Africa is we have a very young population profile. And in my view, this is where the youth dividend comes in. We're going to need to leverage this youth dividends. And the key for me is that knowledge and its effective application and transfer to future generations is going to be the key, really. In terms of addressing the real challenge that we face, our generation can help in terms of setting guidelines and direction and so on, but the people who are going to do the heavy lifting is the youth. And for them, it's going to be knowledge and its effective application. And that's the key part of what we're going to do. Business as usual isn't going to hack it, because if we just continue us on the path that we are without change, it's just like, the guy on the branch with a chainsaw, sawing off the branch, thinking that he's safe. We're going to cut off his very survival system. And that's the challenge we face in Africa, in my view. So what I've just done is what I call a preamble, really, introduction and overview. And I'm going to start to get into the meat of my presentation. But it's going to start with who I am and motivation for this talk. I've done a bit of that already. Share some relevant life experiences in this regard, and my quest for knowledge and information, and then now sharing that knowledge for the benefit of others. So the outline of my talk, like I said, I've done the preamble and backdrop, Africa's particular challenge, talked about rapid urbanization, the rural to urban migration, and so on and so forth. And then the meat of my talk is going to be bridging the gap through innovation, but in particular, leveraging what I call the power of CFD, and then go with some take-home messages, and then we can have a discussion afterwards. So my personal story, who am I? Ghanaian by birth, did my first degree at KN University, civil engineering. I believe maybe some of my colleagues probably are on the line. I invited a couple. And then when I finished, I worked as a teaching stroke research assistant at KN University under Professor Albert Wright. And my first experience of real world problems was there was a Tafo agricultural station and they had an issue with their water system. So obviously tech, we are the experts or the university, they came to a civil engineering department and asked for some lecturers or some personnel to go and help them address the problem. So I went with one of my lecturers who was more senior to me. We went to Tafo and we couldn't solve the problem. I had no clue. I mean, I was fresh from college, and he happened to be more of a hydrologist and a water resource person. So we were there. We just couldn't solve the problem. So I said to myself, if I have the opportunity to go abroad to do my studies, I want to make sure that I don't come back until I can solve the problem at Tafo. And now here, in hindsight, Tafo was a simple problem. It was mainly what we call water hammer, and all they needed to do was to provide some surge vessels and stuff like that. But I had no clue. My training had all been theoretical, no practical knowledge, no practical experience. So, well, I went to London to do my PhD, master's and PhD Imperial. I finished looking for a job. I couldn't find a job. I had to do taxi minicab driving in London for a while, and then prayed to the Almighty and gave me a brainwave, and I offered my service for free to a couple of consulting companies. And that's how I got my foot into the doorway. But everything happens for a reason. Driving taxi meant that I'm an introvert by nature. I was telling John that we all both June born, we tend to be quiet. But being a taxi driver, you realize that you start to learn some life skills. Because when you are nice to your passengers, they give you a hefty tip. And that helped me along the way. When I started to work as a consultant, my client relations improved because of my taxi driving. Anyway, so I worked as a consultant and I got some consulting experience in terms of design and stuff like that. But I also realized that I wanted to acquire some experience to do with actual technology, how things are done, built, and how, So opportunity came where I joined Hydro International, they're an equipment supplier. And I actually took a pay cut to get there because I thought I needed that skill set to add on to. Little did I know that I was going to spend, over 2 decades there, actually helping them to develop their technology, helping them to market the technology, doing some academia, industry liaison, developing a number of patents, licensing these technologies to other countries like Japan, Korea, distributors all over the world. So very valuable experience, realizing the value of intellectual property. But in the process, I had what I call an aha moment of how we can fast track Africa's development, leveraging innovation. And this is where things like CFD come in. And since I had that aha moment, my focus has been how do I come back to Africa and help address this as my key focus. Obviously, in Hydro, the roles I played there were including the technology director, innovation director, and also liaison with academia. Became a professor at Liverpool John Moores as a visiting professor. I've had other liaison activities, but just to highlight that you don't need a massive team to make an impact. In Hydro, I joined Hydro in 1992. The company floated on the London Stock Exchange in 1994. The managing director at the time asked me, what do we need, if we have unlimited resources, what would we need for R&D? And I suggested CFD at the time. We didn't know the potential and power. But just to give a sense of when, for example, we had about 8 products with a turnover of 6 million in 2001. By 2008, we had a turnover of 30 million with 35 products. When I exited Hydro around about 2015, turnover was well over 60 million. And with a very small R&D team, we were able to accomplish much, a lot. I'd like to talk about what I call influencers. Obviously, my parents, my dad, my mom, fortunately, they've all passed. My family, in terms of my wife and my daughter, are key. But when I started my MSc, there were very few Blacks doing postgraduate studies. And I took a lot of inspiration from a guy called Ken Iwogo, who was a professor. He was in Bristol University. I looked around and he had written a few papers, so that gave me a lot of encouragement that Blacks can also do. But anyway, when I started working with Hydro, I was fortunate in the sense that the managing director, Tim Lam, who we see there, unfortunately he's passed, he was somebody who was what I call colorblind. He was interested in the business and doing what you can do for the business. So within 2 years of joining Hydro, I'd been made a director of technology, and the rest is history. But I was fortunate to meet one of the guys who was a father of one of the founders called Bernard Smithson. He had developed some technologies in the 60s, 70s, and it needed real commercialization. And this is where Hydro was set up as a company to look at how it could commercialize some of these technologies. And we're involved in, developing enhanced versions of those technologies. And the key about Hydro was that a lot of the equipment there or technologies had no moving parts, no power requirements, a lot of them based on vortex technology, but very effective, very efficient. The other major impact in my life was a guy called Victor Schauberger. He just introduced a way of thinking where he says comprehend and copy nature. He says we move things the wrong way. We need to change direction. And I'll come up to that in a bit. But this is Bernard Smithson. He initially developed a lot of models in his own home. He had an award by the US EPA, but it took a while for his stuff to become commercialized, maybe 20 years or so. I joined Hydro and my team had things like a smart award given by UK government department to develop a self-cleansing CSO screening system. Again, no moving parts, no power requirements. It does a number of unit processes all in the one device. I'm not going to go into the details of technology. But they have about 35 of them already installed in places like Namibia, Belgium, and so on and so forth. And just before I moved to the US, I was given an award by the British Water. I'm the inaugural winner of the Outstanding Individual category for innovation. Then I had to move to the US. So it's like starting life all over again, different environment. But in the US, again, with academia involvement, did some work with a guy called Professor Bob Pitts at Alabama. He had developed something called the upflow filter, but he needed commercialization. Based on my experience with, working with academia, we're able to then take that product on and commercialize it and take it from a university developed a prototype to an actual product. I'm not going to go into details of that, but just to show some of the background and experience. So in terms of my evolution, I've come to what I call thinking along a different paradigm. And I believe that there are new paradigms that are needed. The old paradigm is involved what I call costly traditional solutions with a downstream focus. So for example, you look at flooding that occurs somewhere downstream in a catchment, the focus becomes the drains there are inadequate in their size. We need bigger drains, bigger tunnels, bigger, all downstream. And so you could instead do a new paradigm which focuses on upstream. So my mantra is that, for example, when you take flooding, I say prevent the rain from entering the grain very quickly and you take away a lot of pain. Use innovative and efficient technologies upstream and you get a lot of gain. So again, with Victor Schauberger, change direction, look upstream rather than downstream where the problem manifests. And I'll touch on some of these later on. But for now, my focus is how do I look at adapting the blue infrastructure for local use? Because some of these technologies are not in your standard textbooks. They are becoming more and more, for example, Dave Butler wrote a book on urban drainage, which we contributed bits in there, which, so basically these technologies are not widely used, but they are applicable for Africa because they have no moving parts, no power. So my focus is how do I adapt these for use in local environments? And I think this is where collaboration with higher education institutions is going to be key. And then I'll be providing workshops and training to help develop local expertise. My view is that we need to develop and leverage these new technology and get some fresh intellectual property. Some of these technologies are past their patent life, 20 years over. I believe we could re-engineer some of these, adapt them for local use, and then in turn acquire intellectual property within the region. And that might be scope for using that globally. The picture you see there was technology transfer to Koreans, Hydro and the team there. So when we look at cereal ridge as a case in point, the 20th century marked major transformation. You take UK, for example, and Europe and probably even North America. It's said that the humble sewer has probably done more for public health than the developments in the field of medicine. When you look at it critically, what the humble sewer did was prevented direct contact between the human and its waste. That break in the direct contact, is what caused improve in public health. And so the sewer is the best medicine, Holds declares. So in Ghana, do we have sewer systems? That's a question I have. Accra, we have a rudimentary sewer system that has not changed in 50 years or so. But I happen to be one of the supervisors for an Iraqi student, Allah. He's the guy in the middle. And our couple and I were his supervisors. He did his PhD on doing an innovation in sewage system, which I believe is going to be transformative. Now, the manhole is one of the main elements of a sewer network. It's a structure that's used to gain access for sewers for inspection and maintenance. Going back in time, the first sewers were what we call combined sewers, where you had both this foul sewage and stormwater runoff all going through the same pipe. And in time, they realized the adverse environmental impacts of that. And now the standard is that you need what we call separate sewers, where you have one for foul flow and one for stormwater flows. So obviously that makes your infrastructure quite expensive. You need two pipe systems, two manhole structures, and so on and so forth. And what this innovation is, first of all, why the need for the innovation? The need for innovations in sewer technology is global, given the unremitting pace of urbanization, increasing populations, rural to urban migrations. We also have an issue of aging infrastructure, particularly in the developed world. And obviously there's uncertainties associated with climate change. We have existing sewer designs that go back over a century, a day back to the previous century. But however, relatively recent developments of new materials, inspection and maintenance equipment has made it possible to revisit this design, which is what this student did as part of his PhD. And really, what we require, innovations that facilitate cost-effective and space-efficient sewage infrastructure in space-constrained urbanizing environments. These are urgently required to help countries meet regulatory requirements and SDG goals by 2030. And what his research did, he, sometimes in hindsight, you look at something and say, oh, I could have thought about that. It's very simple. But what he looked at was how he could combine the two sewer pipes, the stormwater pipe and the foul pipe, in the same structure, but avoid them mixing, because you don't want them mixing. You want the foul flows to go to your wastewater treatment plant, and then maybe your stormwater, if it's quite clean, you can return it into the receiving environment. But sometimes you may need to do some treatment on stormwater as well, runoff. But you don't want to mix your foul sewage with the stormwater runoff. So he devised this manhole structure that allowed him to combine the two pipes into one chamber, but the two systems do not mix. Very simple and ingenious, and he's got a patent for it. So
the process for separating an existing combined sewer system, starting with excavating the soil around the existing manhole.
I think we've lost the sound, unless it's just me.
Took the covers for both chambers with two accesses for storm chamber and one access for the sewage chamber. And by this, we get a new separate sewer system, existing one use for foul flow only, and the new external one use for storm water flow.
So this is how you can separate existing combined sewer systems. So use your existing infrastructure. You can optimize the use of your existing assets through this. And then when you have a new infrastructure, this is how you install a new separate sewer system.
The process for installing a new separate sewer system. Starting with excavating the soil for the external stormwater chamber and then the soil for the sewage chamber at the bottom. Then install the bottom of the sewage chamber and laying the foul pipelines. After that, set up the base for the stormwater chamber, an external wall for the storm chamber and internal wall for the sewage chamber. Install the pipes of stormwater networks above the foul pipes in the same trench. Finally, set up the covers for both chambers with 2 accesses for storm chamber and 1 access for the sewage chamber. And by this, we get a new separate sewer system, having 1 manhole structure and 1 trench to accommodate stormwater network above the foul network.
So this combination allows you to use just a single trench for both your combined sewers, And as part of his PhD, he did a lot of verification and validation. He did structural performance, hydraulic properties of the new design. He did all this in the lab scale, but also actual physical testing, both structurally and hydraulically. And he found that the new design had a lot of advantages, both structurally. This is a structural test, with simulated loads, like heavy traffic loads and stuff like that, and the deflection and stuff like that. He realized that with the 2 pipes in the 1 trench, there was some structural benefits for that system. He also did some hydraulics as well as computational fluid dynamics. These are just some, he compared the existing conventional manhole design with this new manhole arrangement, looked at things like head losses and stuff like that. And just of time, I'm not going to run the entire video, but this is the conventional manhole design. The next slide shows this new manhole design. Again, also hydraulic test, computational fluid dynamics to understand the hydraulic flow patterns, head loss relationships. And basically, it found out the new system was more resilient to stormwater flows in terms of preventing flooding. So it had major advantages over the existing conventional designs. So in addition, you can see that this kind of novel manhole versus conventional examples of savings on a typical development. The conventional manhole, you need 2 separate pipes. Probably sometimes you might need two trenches. But then the single new development, you get just 1 trench. So it decreases the number of manholes by about 50% on a typical scheme, which decreases construction cost and time by more than 40%. Also makes space for other utilities and services, in a lot of urban catchments. You've got a lot of congestion of services, cable, gas, fiber, and so on and so forth. So in our view, this innovation could save developers, municipalities, water utility companies, and their customers several $1 billion annually. He's currently at the stage where we're actually doing full-scale demonstration trials and testing in the UK and Europe. But to summarize, the innovation is a novel manhole design that accommodates both foul and stormwater sewers without combining flows. The concept has been proven through exhaustive and comprehensive numerical simulation and physical testing of prototypes, which form the base of the 4-year PhD work. The device and system has been patented, so he's looking now to commercialize through a partnering arrangement. And obviously the benefits include significant decrease in the number of manholes, as I said previously, decreases the footprint and construction cost and time. It's suited for space-constrained areas such as narrow streets. We have the proven structural and hydraulic integrity and performance advantages against conventional. So it's well positioned to leverage advances in sewer technology, including materials and things like no-dig, so in our view, this represents the 21st century solution to an old and persistent problem. The issue we had with conventional systems date back to the previous century, and this novel arrangement, in our view, is what we need for the 21st century in terms of sewerage systems. So that's one example of blue infrastructure. Now, what I want to talk about is leveraging the power of CFD to accelerate technology developments, because I think that's what holds the key for how we may leapfrog the developmental cycle. And I'll go to use some case examples drawing from Hydro experience. In Hydro, we had our own labs, test rig for flow control devices. We also had test rigs for solid liquid separators. So we could test some of these systems at near full scale. We also had to have what we call field demonstration units, because when you have novel technology, a lot of time you go to a client, he says, where have you used this before? Show me that this works. So we had to have these pilot units, which we took to client sites to demonstrate the efficacy of these systems. I also had to develop a lot of analytical capabilities. But in time, when we started a lot of our R&D, it could take a typical development cycle could take about 18 months, maybe 24 months. You build a prototype, you take it to site, test it. Maybe it might not work the way you want it. You have to take it back to the fabricator, do these tweaks, change here, then take it back to site. That cycle could take up to 2 years to develop something fully. But in time, we had a number of people doing PhDs on what I call CFD, computational fluid dynamics, both on the flow control devices and separators. And what we then realized was, in my view, when we started doing CFD, I thought that this was just going to give us what I call relative effects, whether A is better than B, but not actual real life simulations. But as we did the PhD work and continued, I realized more and more that CFD actually mimics reality. And CFD had what I call a barrier of entry. When we started CFD, the cost of the software was about £60,000. The hardware was almost 100,000, because you needed workstations at the time to run these computationally intensive system software. But fast forward, now we have a situation where you can plaster just a few pieces together, and the software is open source. So whereas in the past, it would have been near impossible for a university in Ghana to, acquire the funds to go to do CFD. Now, a student with a laptop, and open source code could do CFD. So the barrier of entry has come down significantly. What I say, I'm not going to go into the details. These are the equation, the Stokes equation. It solves the differential equations. Basically, your domain is broken down into a lot of cells. Those who are structural analysis, it's a bit like finite elements, but basically solves the domain for mass, momentum, and energy. So what we realized was that some of the expertise, particularly external investors, was one case in point, where one of the professors there was one of the people who had helped develop some of the open source code for CFD. We had what we call a knowledge transfer partnership arrangement, where one of our guys did his PhD under the supervisor in Exeter. And that arrangement helped to introduce and inject CFD know-how into Hydro. But it also resulted in developing a new range of vortex flow control devices. And as part of his PhD, obviously, we had a test rig where we could do runs experimentally in terms of physical testing. And then he could run the same simulations on the computer. So you have CFD simulation, experimental testing. And basically, when you look at pressure profiles, you look at the graph on the lower bottom corner, you could see the physical test results, the CFD results. So in fact, CFD was actually mimicking reality. So which meant that instead of having a comprehensive laboratory, a physical testing facility, if you have these computational intensive units, or you have efficient CFD units, and you know how to model, you could be modeling reality. So, I mean, this has evolved over, this guy did his PhD over 4 years or so. But in time, my level of confidence in CFD started to grow when I realized that it was mimicking reality. Some of these flow control devices are used for flood control and stuff like that. I'm not going to go into details of that, but a case in point is Glasgow, where we have 3 flood storage areas upstream. So again, the issue there was flooding. And typical approach to addressing the problem is you look downstream and you see that you need bigger pipes, bigger drains. but you have congestion of services, railway lines and embankments and stuff like that. By going upstream and retaining the flows to within the capacity of the downstream areas, resolve the problem by 3 flat storage areas upstream and using these non-powered, no moving parts devices. That's an example of a flat storage area. The other area, that's the hydraulics, so that's flow control. We had another guy do his PhD at Cardiff University looking at solid liquid separators. And again, he did some work with experimental CFD predictions, and he was getting same, good predictions of removal efficiency on the separator side. So again, this then also, so you're talking about about 10 to 15-year period with experience with CFD, realizing that, hang on, this is actually giving us, we're making reality. And so we evolved some of these systems and some of the innovations. A lot of systems when we started initially were stainless steel because you wanted it to be robust. And but in time we started to manufacture some of these from high density polyethylene and plastics, to bring the cost down. But for me, a particular case in point came when a client came to us and he wanted something. He was looking at a mixer, and typically with mixers you have electromechanical device with paddles and power. And we said, let's look at maybe we could do the same mixing but without any power requirements, external power, by just using a vortex device. But this device had never been built before. And a typical product development cycle means you build a prototype, you take it out to test. If it works, it doesn't work, you take it back to the fabricator and so on and so forth. But here, I was happy enough to, confident enough that CFD predictions would give me reality. So here, we went from what I call the concept to full scale. We never built a prototype. The first prototype we built was actually at the client site. So CFD eliminated the intermediate step in product development. So this is where I had my aha moment and said, hang on, this is what we need in Africa. CFD is a tool, is a key. So on this particular project, we had a situation where we had 2 fermented liquor streams mixing with a degraded primary stream. And you wanted to achieve a certain solids concentration. And this was the system we designed and then tested on CFD. So basically, the red coming in at the top and blue coming in the middle. You wanted to get green, basically. We simulated a number of scenarios, low flows, average flows, maximum flows, and all the simulations were showing that the system would work. So then I had the confidence and said, hang on, we'll go to the client site and build this thing. We won't build a prototype and test. The first thing will be a full scale. So this is, over a development project that would have taken probably a year or 18 months. This was done in a couple of months. So this shows this example of the simulation in terms of mixing. The red is the heavy concentration, about 4% dry solids. The blue is what we call the illustration line, which is the degraded primary effluent coming in. And you can see that the system is mixing without any power, without any moving parts. And it's just using the hydrodynamics of the vortex regime within the chamber to do the mixing. And the effluent comes through the bottom, and you can see that, it's achieving the objective in terms of the mixed product is green coming out of the outlet. And it's what CFD predicted. And then, like I said, the first time the thing was built was actually for a client. So we sidestepped the intermediate step where you'd actually build a prototype, test, and so on. And so the first unit is what you see in the picture, the right bottom corner. Post-construction, we did some commissioning testing, and the system passed. Calculated concentration 0.43, measured concentration 0.39, 0.4, basically. And when I saw that, I said, hang on, CFD is an extremely powerful tool used to gain insights. We had been using it also for assessing competitor devices and so on, gaining insights into processes. But more importantly, it's effective for assessing hydrodynamic regimes, related divide efficacy in different chamber geometries. We know all that kind of work. But this project on the Middle Basin proved for me that it can also be used as a rapid prototyping tool in the development of existing and new innovative products. So in terms of accelerating our product development cycle in Africa, CFD to me is a key tool because It in terms of accelerating the process, it can possibly, when used right, cut out an intermediate step that would have been needed in typical product development cycles. And we don't have time really in Africa. So my next view or next move was, how do I start to inculcate this in the African environment? I happened to be an external examiner at Cairn University at some point, and I did suggest there, but there was very little uptake at the time. And when I was external examiner, there was one student who I read his master's thesis, and really he impressed me. I said, this guy's a brick. Let me take him and mentor him and bring him under my wing. And we managed to get him enrolled at University of Energy and Natural Resources to do a PhD there. I donated a few computers to act as the seed for a supercluster station, and he started his PhD there. But this cluster there was not sufficient in terms of power to do the kind of simulation that was needed. We managed to get him a Commonwealth scholarship to go to Exeter University, and he did part of his PhD at Exeter. And he's now a research fellow at UNAIR. His PhD was on numerical simulation of free surface vortices on multiple intakes. The motivation there was to look at the situation at Akosombo, and I'll come to that in a bit. But the guy at Exeter, who was his professor, was Professor Gavin Tabo, who's one of the world's leading experts in computational fluid dynamics. He helped develop the open source code, OpenFOAM, which is free. So, it's now a question of application. I know we have very bright young students who can apply themselves given the opportunity. So in terms of what the motivation for Martin's work, when we look at Akosombo, the issue there is water levels is very sensitive to water levels. You don't want to go too low, because when you go too low, you get air entrainment in the intakes. You can see an air entrained vortex on the right bottom corner there. So they have to maintain sufficient high enough water levels, but if water levels are too high, then you have the risk of overtopping and so on. So water level is quite sensitive to the issue of water levels. So if you can actually manage to maintain or operate the system at medium to low water levels consistently without incurring air intake in the intake, then you can have more reserve. And the issue that we had with the massive spilling that occurred last year may have been averted if we had been able to look at installing some of these systems. You notice the difference in intake elevations, highlighting the significance of upstream water levels on the operations at the Akosombo. This is part of extracts from Martin's work. It needs further development because he simulated some mock examples there, but not necessarily specifically to do with Akosombo, but he demonstrated the CFD ability to model vortex intakes, vortex structures and intakes. And then more importantly, we looked at how those vortexes could be suppressed with simple devices. For example, a simple plate, an anti-vortex device, could suppress the formation of vortexes at the intake. And in that sense, you could look at a situation where you might be able to operate Akosombo, for example, at lower water levels, which would give you the capacity to take in more in the peak of the rainy season. These are the two servers that I donated to Sunyani. I'm now encouraging them to have something similar to what Martin was able to work on when he went to Exeter, which is a bigger cluster. But for training purposes, this is adequate. So to make that knowledge more widespread, Martin has included CFD as part of the course structure at UNAIR. He's run a few workshops. These are some of the students who received some initial training there. My vision is to get CFD to become more widely used and more widely the uptake being in terms of bigger penetration across the nation. So implications, in terms of trends, threats, and opportunities. For me, it's important to move away from the mindset that says we need to depend solely on technologies developed in the Western world. Africa has the potential to address its developmental and environmental challenges with non-conventional innovative technologies with global relevance and impact. However, there's a need to be more open-minded. We need to think outside the box and take bold, proactive steps with sustainability concepts and leaving a legacy for future generations. We need to learn to harness our creative potential. I believe we have innate creativity. Now, every major development is a break from tradition or conventional ways of doing things. Change is an inevitable part of life. You are either a change agent or you are controlled and influenced by others' change agenda. We need to endeavor to be change agents, think outside the box, and accelerate our pace of development if we're going to make an impact, particularly given the enormity of the challenges we face in our development on the continent. Some of the challenges we face, I'm starting to wind down, things like exposed surfaces which are prone to erosion. I believe we can beautify our landscapes with things like porous paving, using crash recycled tires. These allow water to percolate into the ground rather than the situation we have now where people build and pave the entire compound. These examples of this kind of system being used for hard standing areas, drainage strips, roof gardens, golf courts, trails. Think if you have things like supermarkets with take a crowd more, the whole car park is a massive impermeable surface. It could use these kind of systems to make it more. The other area, for example, we have a focus on dredging. And for me, I think it was this quote was from Paul's Africa. Those were 2016, where Band-Aid in terms of the dredging, it's not going to solve the problem. So this is a direct quote. According to me, dredging could not be counted on as a preventive measure to the floods because of the nature of Accra's drains. We have a lot of exposed surfaces. The more exposed surfaces you have, the more erosion you get, which will wash sediments into the drains. Part of the issues that we need to address and prevent the erosion of sediments into the drains in the first place. That's where the form pave and stuff like that come in. For me, dredging is the bandage. Are we going to be dredging every year? Which I question, and I think we're still doing that. I believe we can leverage some of these technologies. For example, this is CFD looking at what I call a sediment washing device. The blue represents material that is light, oils, things are floats. The red will be the sediment. So you can easily separate these things with a vortex type device, separate the sediment from and some of these systems are already in existence. This is just showing the boundary layer in terms of how these systems wash. This is some of the transparent. So you can see the boundary layer effects in terms of washing effect that systems can do. So for me, for example, these high efficiency technologies, where could we use them? I believe assisting with the strategy or technology for reclaiming the dredge materials from the Odo River Basin and recovering and leveraging these as a resource for building materials. We have more than 1 million cubic meters of sediment in the Odo, and we're going to carry them and carry them to landfill, whereas we could capture them as fine grit and produce a clean product that could be reused for building material. And where could this be? And there's a guy called Nelson Watson, I think, Nel Plus Kugana. He used some 13,000 or so kilos of plastic. He takes a combination of plastic and sand to build these paving blocks and building materials. He's built the first house. So this could help resolve the issue of low-cost housing. I don't think he's had any, like appears we don't have a system in place to help scale up. He's got some innovative technologies that he's developed himself as part of his experience, where he casts and extrudes the material. It's a combination of sand and plastic. Again, I think he could leverage this further to develop permeable paving and stuff like that, but he's not being supported, in my view. Another piece I have is with the potential of rainwater harvesting. We have a lot of massive roofs in our catchments, but we have a tendency now to develop our catchments or build our houses and pave the entire compound, whereas in the past, our grandfathers and fathers had compounds that had a lot of greenery, allowed some of the runoff to percolate and soak into the ground. We're now causing massive runoff, and that's part of the challenge we face in terms of our catchments. And I believe rainwater harvesting has a lot of potential, not only in terms of helping to address the downstream flooding issue, but in terms of sanitation. Look at the public toilet on the left compared to the one on the right, where you've had some rainwater harvested, which provides you with water to help with improving sanitary conditions in terms of washing and so on and so forth. Again, this is rainwater harvesting for a school, so the kids improve sanitation, water to wash. Further, I believe that rainwater harvesting, if it becomes a national policy and we engage properly, it can actually create an industry. That's what's happening in Australia. It will create jobs on a local basis, just for not in terms of artisans and retrofitting these roof gutters and stuff like that, and systems, but also, you know, systems for equipment suppliers. So we need to look at transforming our local environments, you know, from this hard paving to soft greener environments, living more in tune with nature, and so on and so forth. I'm not going to go into details of all that, but if we control runoff at source and incorporate water into our living space in our local environments, we can then look at even things like green roofs or blue roofs, incorporating water at an early stage in the cycle, not allowing it all to run off downstream quickly, but capturing it upstream. Again, I mentioned the systems. You know, there are all sorts of types of systems that could be used. Even in a rural environment, you can have large clay pots. But more importantly, even in our homes, once you start to re-harvest rainwater and so on, you could then have herb gardens. We've gone away from our traditions where in the past we had things like herbs, akukobesa and stuff like that within our, you know, within our nearby our homes and the gardens in our homes. We could get back to those kinds of situations, which would improve conditions for us in terms of our health. And also, when we have water that's stored locally in large systems, we have a situation where we have fire and then there's no fire tenders arrive, there's no water around, and it's all this kinds. It can help resolve a lot of these kinds of issues. Do we have about 5 minutes or so? I just want to share the issue about innovation in terms of Africans are very innovative, but
Between
I think it's
200 and 1,000 batteries go into each power tube made by Marco Amoboateng and his team. The batteries are themselves recycled from old laptops.
We test each and every one of them to see if they are still good or not. So the good ones that we get, then we try to package them into these.
Mark Amoboateng's regular job is lecturer at the University of Energy and Natural Resources in Suyani in Western Ghana. He set up this workshop 2 years ago. He designed the housing for the battery on his laptop and recently began using a 3D printer for the high precision work. Once completed, the power tube can be hooked up to an inverter charger, which then serves as an emergency backup generator.
It charges it out, and it also sends power out when there's the power is off and stuff like that. So this basically the whole system that you need to power your whole house.
The power tubes have an operating life of between 2 and 10 years, depending on the condition of the batteries. Then you just replace them with other used batteries.
We try to look for waste batteries and try to give them a second chance because they are polluting our environment. So we go around scouting for these batteries, okay? There are a whole lot in the system. What happens is that most of the dealers sell them as scraps and other stuff.
Ghana's capital, Accra, has a thriving used electronics market, but in other cities too, such as Kumasi and Suyani, people do a lot of tech recycling. Mark Amoboateng has found suppliers of used batteries across the country. Anthony Ako from Kumasi started repairing electronics goods 13 years ago, mostly computers. His store has also become an emporium of used batteries, which he now sells to Amoboateng and his team. I saw right away that this was a good business opportunity. They always pay on time and they're clear about what they want. That's why we try to hold on to our electronic waste, especially our batteries, and no longer give them to the scrap dealers. 10 power tubes have been sold so far. They don't come cheap. They can cost between 870 and 1,500 euros. Their customers include both private individuals and public sector institutions, such as this healthcare center. If there's power outage, they just turn on the power tube.
Using power tube for several years now. In fact, it has been of a tremendous benefit because there's a power fluctuation in Accra here, especially in the Hatcho. So ever since we started, it has even given us a more powerful electrical strength for our laboratory machines.
In his quest to provide viable solutions to power shortages, Mark Amobwateng always takes the environment into consideration.
Batteries we are unable to use, we keep them. We are looking at alternative ways of recycling them so that they do not go back to pollute the environment.
The power tube inventor and his team need more financing in order to increase production. Finding old batteries will be no problem here in Ghana.
Yeah, so the challenge is
Between two
scaling up, for him. Where's the support? Another one I just want to show us an example is this Nigerian who has been working on drones for aerial surveillance, detecting hideouts of criminals with caves in the forest area. This can be leveraged to help address the fight against Galamsey, in the forest areas. Obviously, where people have their camps, they have to have fire. They have to eat, so they have fire and stuff like that. This can be used to help assist in that process. So back to evolution in thinking and paradigm. I said, prevent the rain from entering the drain very quickly, take away a lot of pain, use innovative, efficient technology upstream, you get a little gain. So my end point, what's in store for this future millennia? The future, in my view, depends on the choices we make today. We need, however, to understand where we have come from and where we currently are in order to be able to chart appropriate paths towards a more sustainable future. The choices we have are either individual responsibilities and collective responsibility. I believe we need to, as a collective, all, put our hands to the pump and address these challenges that we face. If we don't, we may end up being extinct. We don't want to be extinct like the dodo. We could leverage what I call indigenous knowledge. One of the things that blew my mind is, as a water engineer, when I found out that what our ancestors and our forefathers had in terms of the cooler was the best form of vessel for storing water. And then I came across this where people are using like a double-walled system of the cooler technology as a refrigeration system to store vegetables. It's considered double wall. The sand between the two walls has a bit of water. The evaporation keeps the system cool. So these are some of the things we need to start looking at in terms of leveraging tradition based on African heritage, championing what I call African excellence. I want to end on a quotation from our founding father, Dr. Kwame Nkrumah. What he says is that divided we are weak, united Africa could become one of the greatest forces for good in the world. I believe strongly and sincerely that with the deep-rooted wisdom and dignity, the innate respect for human lives, the intense humanity that's our heritage, the African race united under one federal government will emerge not as just another world bloc to flaunt its wealth and strength, but as a great power whose greatness is indestructible because it's built not on fear, envy, and suspicion, nor one at the expense of others, but founded on hope, trust, friendship, and directed to the good of all mankind. And I believe that's the direction we need to go. So I started off my talk with the premise that we need to accelerate Africa's development by bridging the current technological gap and addressing the infrastructural deficits through innovation. And like I said, I keep saying Africa has a huge dividend that needs to be leveraged. And the way to achieve this is through disruptive, eco-sensitive technologies, blue infrastructure. So this is my last slide, my end note and food for thought. When I commune with the Lord and ask him what's the key message for Ghana as a nation, and this is what keeps coming back and back to me. And this is a quote from 2 Chronicles 7:14. If my people who are called by my name will humble themselves and pray and seek my face and turn from their wicked ways. Then that's a condition. I will hear from heaven and I'll forgive their sin and I'll heal their land. Turn from their wicked ways. Ghana is a nation that prays a lot. But what are some of the wicked ways? We're destructing our environment with things like galamsey and so on and so forth. It's very despicable. I want to end on this little video here, which was sent to me by one of my friends who I think it was a prompting from the Lord in terms of the timing for this video. I'd seen it before on my WhatsApp platform, but I thought it was apt to share.
Hello,
as the
everyone.
ending
This is a view
video.
from Hotel Ivoire. And what you see here in Abidjan is the Lagoon Ebrié that has been so well integrated into the very fabric of this beautiful city that you think you are in some country elsewhere, but this is La Côte d'Ivoire, next door neighbor to Ghana. In fact, from the border at Noé, Lubo to Abidjan is just about 2.5 hours, right? And every single river, every single lake, every single lagoon, apart from the ones that Ghana has destroyed, is beautiful, it's crisp, clean, and it's really, really, really just unimaginable. How beautiful the same group of people on the same strip of land in Africa's west coast. And one group can decide to destroy beautiful rivers they have and lakes and streams in their quest for gold. And the other just keeps this so crisp and clean. It's beautiful. Ghana food. My Ghana people. It's about time we realize the folly of what we have done and keep doing. About time we changed, because what we are doing is unsustainable. Just look at this. Look at what our neighbor La Côte d'Ivoire has done. This is the lake. This is a lagoon that runs through the city of Abidjan. And look at how well it's been integrated. You don't see a single brown or yellow. All you see is natural, beautiful.
Right. So that ends my talk, guys. Ladies and gentlemen, thank you so much for coming. And I open up for questions. I'll hand it over back to John. Thank you.
Thank you. Thank you very much, Bob. You've given us a lot to think about, so much to think about. Very, very loaded presentation. In a moment, I'm sure for those of you who do not have any clue what CFD is and sewage and drains and all that, there's still a lot of, there's a lot to gain and understand from this whole presentation. And I'm sure as we go through a couple of questions, you would appreciate that the essence of the presentation is on innovation. And he shared with us different types of innovations that others have come up with. And in your own area of work, it doesn't have to be in the field of storm drain or flood management or anything. In your own area of work, there is something different you can do. There's something special you can do. There's something that others have not thought about that you can think about and do that will set you apart from others. So this is very, very insightful presentation, Bob. We thank you so much for that. And you already have a question on the platform. I think so. The network today has been particularly very bad. I don't know what's going on. I saw a lot of people coming in and out, and I was in and out a couple of times myself. But I think somebody wanted a little bit more highlighting on the use of plastic waste for construction purposes. If you may just go through that very quickly for the benefit of those who dropped out of the call when you talked about that, please.
Right. There's this guy called Nelson Watson who has a company called Nelplast. And he used to work with some Chinese people initially. He's fabricated equipment that allows him to melt used plastic waste, add it to sand in a particular ratio, and develop blocks or bricks that can be used as building materials or paving stones. And I think the last time I checked, he was looking to leverage that device as roofing sheets. But the picture I showed on the slide was a building that he had actually built using that material at somewhere in Accra. I can't remember exactly where. And he'd been struggling to try and get support and funding on projects. I think he had been liaising with the Ministry of Science and Technology, and they'd given him a couple of projects and stuff like that. But to me, this is a potential revolutionary idea or technology that needs to be scaled. It can generate a lot of jobs on a local basis. I mean, his machines can be fabricated. You know, you have a situation where we got fabricating capacity or capabilities in places like a magazine and so on and so forth. We should be looking to improve our ability to fabricate equipment and devices. It could easily be something that you set up similar thing on a one district, one, you know, not factory, but one district basis where it could be used locally to, you know, to bring down the cost of the whole issue about affordable housing, in my view. So yeah, that's what I can say for now on that. But some of the challenges that we face as a country that we need innovation. My view in terms of innovation is leverage. We need to go back to look at what our forefathers did and look at bringing them into the modern era. You know, a case in point is the kind of buildings that we had with mud and using local mud and what's it called, wood. Those buildings were such that, you know, they were temperature modulating. So in the heat, you go in there, they're cool, you know, compared to now where people are building their houses where they have double glazing and in a tropical region. So when the lights go off, you are in an oven, you know, there's no cross ventilation. And not only that, but if you delve into more, you know, more esoteric things in terms of things like something called the dielectric constant, in terms of building, allowing your aura to breathe and stuff like that, then, you know, metal buildings are a no-no. You know, they're like Faraday cages for our bodies, and you know. So, my view is we need to start to think about our indigenous technologies and then bring them into what I call the modern era. You know, leveraging, you know, understanding these things and not thinking about being a cake or you know, bush systems or whatever. Take the coolers as case in point. You know, you could have ceramic filters that then store the water locally, you know, in your coolers. And those water are, you know, much healthier for consumption than water stored in buckets, like plastic and metallic buckets and the like. But anyway, I hope I've answered the question on the plastic for building materials. But if not, I can look up some web links to the guy Nelplast, you know, for further information. He's got some videos on
Yeah.
YouTube describe the technology and what he's doing in that area.
All right. Thank you very much, Bob. I think that's very useful, and I'm sure we'll share the presentation as well. So, am I right that we'll also share a presentation?
Yes. Mm-hmm.
Yeah. Okay. So, I mean, well, we've had some comments on how great a presentation is. If anyone has a question, please put a question on the platform, or you want to raise your hand, or you want to just unmute and ask your question. We'll just take a few questions because our time is fast spent. But Bob, talking about all of these things, Okay, someone has a question here. It says, you mentioned that dredging the Odo River is not a solution to Accra flooding. Does it mean any project to dredge the Odo is not necessary? What technology would you propose? And thanks for the presentation.
Right. Okay. I'm not saying that dredging is not necessary. What I'm saying is that we probably need to dredge once, not every year, and so on and so forth. And even if we're going to dredge, we're going to make use of the materials that we've dredged. I believe that the sediment that we find in the Odo is what I call relatively clean. It's not heavily contaminated sediment, so it's relatively easy to wash in some of these devices. So at the point of use or point of capture or point of dredging, if we could leverage the use of some of these technologies, we could be we could be cleaning up the sediment and then bagging them and then using that sediment as inputs into the building or construction industry, rather than dredging them and then cut them. Accra itself is very congested. Transporting these into specialized landfill sites and the like. And this is just technology that takes demonstration. I don't think, it's been used elsewhere. Just that we don't have examples of its use in Ghana or Africa. But the technology has no back. So what stops a pilot project being undertaken, looking at how we may leverage some of these technologies for that kind of application? So that's where I'm coming at it from. I look at the big picture and see these things as possibilities. And I'd be happy to engage, but for now, my focus has been, what do I transmit to the next generation? And that's why a lot of my focus has been on academia, the higher education institutions. I've been supervising some PhD students. I've got one that I'm supervising now who's doing work on separation using computational fluid dynamics and actual physical testing and stuff like that, trying to find somebody to continue Martin's project, because next step in that process is I want somebody to start modeling the situation at Akosombo itself. Martin has demonstrated that we can use CFD to look at the challenge. We don't need that to go forward. He's now a research fellow and is loaded with academic work in terms of teaching. So, he is not in a position to continue that kind of research. You really need some PhD students in that sort of area, yeah. So I'm hoping that some of these talks will stimulate some of these I know we have very bright guys, brilliant students, all they need is opportunity. And now with things like the barrier of entry coming down, and the past was unimaginable, is going to find 100,000 for software or 100,000 for workstation. But now with, just a case in point, there's a Korean student, 18-year-old, who used CFD to design a system for an aircraft in terms of air distribution. And it was very patented, and he's licensed it to Boeing.
We something to feel for this and the like. It will feel come on.
Sorry.
Sorry about Karen. Yeah, it's muted.
Yeah. I was saying that an 18-year-old used CFD to design an aerofoil that's being used by the aircraft industry. That shows the power of CFD.
Yeah. Thank you very much, Bob. So I think the question on the outdoor, I'm very much involved with the dredging thing under the Garrett projects. I think the approach is quite different from what used to be the case, where the reuse of dredge material is very much on the table within the current what we call performance-based dredging. But not to bore everyone with too much detail. But you are right. We need to look at ways of minimizing the dredging, but also make use of the materials, and that is part of what we are doing currently. Right. There is. Okay. I think I saw Gozi's hand. Gozi, please, if you can ask your question. And there are a few questions in the text box that I'll read thereafter.
Oh, thank you, John. And Prof. Well, thank you for your presentation. Brilliant presentation. I think in your last response, you kind of touched us of the question I was going to ask. And really, it's about, technology and innovation. As you've identified, there's a lot of talents within the youth. And it's sad that sometimes this talent cannot be taken opportunity of. You've talked about how you try to push this, but I think on a more, probably at the government level, how can we get this, create a system where we can snatch such talent, and probably referring to our educational system, is there a way these things can be incorporated?
Yeah.
It doesn't
Yeah.
have to be always at universities, it can be more apprenticeships, engineering firms, all coming into place, because I love these young children are gifted, and in the video you just showed, I've seen a few of them, and it really saddens me that such talent is not being taken advantage of.
Yeah. I'll share an experience from what I call the governmental level and why there's a need for mindset change in the way we think. Personal experience. It's going back to several years. I came to Ghana as part of a British water mission and, did the presentation to the ministry and stuff like that. And then I wanted to gain a one-on-one sort of opportunity to speak to the minister responsible for that particular ministry. I went to see the principal secretary. It was very difficult to try and get an appointment to get through. So it was a time when there was communication. So I went to the central communications and then sent a handwritten note to a company, to Hydro, for them to fax on letterhead back to the guy. So the next time I went to see the guy, I said, "Oh, I had written that letter." But because it had come from Europe, from the Hydro, saying that, accord Professor Andor or Dr. Andor at the time, all the blah, blah, blah. He now gave me, go for that trouble. Then he made me to go see the minister. But at the time, that minister was actually, didn't have a background even in the area. The minister was an people teacher or something with very little background knowledge in the particular area, So those are some of the barriers, in terms of the governmental side of things. It's difficult. Believe you me, I've tried. I don't want to say much. I've gone through to some of the highest channels possible. So it's tough. But as a country and as a people, we need to change our mindset, really, and think in terms of possibilities and encourage the youth to be daring and be bold and take proactive steps. It's in them. It's in there. In terms of innovation, the innovation is in their DNA, but it needs to be encouraged and it needs to be it needs to come out. But some of the challenges we face, when we go back to my previous talk on the platform, this health and optimizing, some of the challenges we face is that we are not in tune with the divine. We have suboptimal bodies that are not allowing us to tune in because of the kind of foods that we eat. When we're not, I'm serious about this. We're generating bodies that are not allowing us to download. Our ancestors downloaded directly from divine. How did they know about this herb or this plant and so on, to cure this and that? It was divine knowledge that was being downloaded. Seriously. Example for that for me in Ghana right now is what's it called? Sapo, the Kantanka guy. He needs to be held by government and helped because he has been leveraging, he's been doing agriculture based on natural herbs and natural whatever herbicides that you can even drink, not non-poisonous, non-toxic, and he's been sort of doing heirloom plants and yam that grows on, some of these rare, and he's doing a lot of farming, organic, and farming methods that are non-destructive. We have a situation now where we're using herbicides and pesticides, in a non-controlled fashion. And what we're doing now in our as a part of our farming practices is, we have ecosystems with biodiversity. And when we were growing up, you could see caterpillars and centipedes and so on. They were boring holes in the ground to allow the water to percolate and infiltrate into the ground. We've killed all of these insects. And now the ground is being compacted and hardened. So what we think is permeable areas is not allowing water to percolate and infiltrate into the ground. Then we have massive runoff going into the water river, and we are seeing the massive spills. I don't want to go there, but there's another issue which is to do with what I call temperature gradient. But that's for the water resources people. So we have big problems because we've spoiled our western river basins, the Pra, Cobra, and so on and so forth. And now we're doing the Galamsey and even started to tackle the water in the upper parts of the country. The water is the only pure water left for us as a country. And if we spoil that as well, might as well pack up as a country and forget it, in my view. It's a serious issue. The most important thing, in my view, for our leadership is to address this Galamsey issue. It's leading to a lot of kidney disease and stuff like that. We're going to have a generation of people who have been, poisoned at infancy with a lot of toxic materials, heavy metals, mercury, arsenic, and I don't know. Sorry about that, but it's something I'm very passionate about. It's
Yeah, that's all right. So there's a question here. We'll just take this couple. We can wrap up. Yeah. You're welcome, David. I'm answering for Prof. So how can academia bridge the gap with industry to upscale research innovations and findings?
Academia should, in my view, start to liaise more with industry. Yeah, and and increase the practical content of the coursework that they do. It's too theoretical based. A lot of the researchers, it should bring in a lot of industrial practice and experience to bear in the course modules and the course content. Foster a lot of internships and the like, and do research that are applied research. We have take the problems that we face as a country and put them as challenges to be solved by academia.
Mm.
And take advantage of folks like me who have some of the experience in terms of academia, industry interactions, and product development and the like. And it's difficult. Sometimes I have to go begging to run a seminar or workshop. It's
No. Right. So
Can I ask a question?
Please go ahead.
Sorry?
Please go ahead.
Yes, I wanted to hear a little bit more about the rainwater harvesting, because we seem to have difficulty with water in certain parts of the country, but when it rains, the water just goes and floods the place and make a mess. Is there any way that we are seriously planning to harvest rainwater, at least if not in all the places, in some developments, that becomes a kind of development that will be made by building contractors who build to sell and things, so to be a kind of way to go. And also, if you can target the areas where it floods in Accra, for example, make good use of the water that causes havoc when it rains. Thank you.
John, do you want to touch on that in terms of what government might be doing in that area?
Yeah. Okay. So there's an ongoing work with the World Bank to actively promote nature-based solutions, including rainwater harvesting. And in fact, there is going to be a forum on the 23rd and 24th of May at the College of Nurses, College of Surgeons, College of Nursing Surgeons conference hall it's on the built environments, hydrology and housing generally. The first day is for hydrology, and these are some of the matters we'll be talking about. But yes, there's a plan effort to actually come up with standards, because the thing is that we don't do it here. So we need to, come up with standards, come up with some pilot projects, demonstrate to people this is how we do it, so that we can actively encourage an uptake of nature-based solutions. The conference is on the 27th and to 29th of May. So I think that's what the plan is at the moment, to actively encourage the uptake of nature-based solutions, including the rainwater harvesting, which is the cheapest one really, and perhaps the most effective one as well. I mean, in terms of slowing down flows into the drainage system, and in terms of reducing the risk of surface water flooding. So that's what I would say, Prof.
Okay, can I also share some thoughts in that area?
Yes.
And I said we need to look upstream for solutions rather than downstream. But where we run out of space in a highly urbanized catchment, we may need to make room for water by leveraging local storage or go on. Accra, for example, take Accra. We've virtually run out of space because we're developing close to a breeze. And I had a student who was looking at the urbanization in say the Odo catchment as a case in point. You look at 1991, the green is showing sort of like forested area or green area. Red is urbanized area. So from 1991 to 2020, you can see that, the trend of urbanization. And now I think the only green areas in Accra are just around the atomic area or the Achimota forest. We develop all the way a breeze in the north, right? So when you look at the trends, really, I have what I call the tipping scale, the turning point. It was around about 2000. Past 2000, 2011, 2010, 11, we had more built up area than vegetation in the catchment. Now 2020, it's about 70% or more. I think now probably more like 80% and 25% in terms of the. So if we had started to take some measures around the turn of the millennium, sort of around 2000, we had a better chance than what we have now. Part of what he did as part of the work that he was looking at is looking at roof areas, satellite images and stuff like that. And we did some rough conservative estimates. For example, just on the basis of roof areas and estimated flood storage, that's potential storage volumes. When we take the June 3rd, 2015 flood, it's about 131 millimeters rainfall in 6 hours. Assuming 100 millimeters capture, that represents probably greater than 600,000 meter cube of storage. So that shows the storage potential that can be leveraged from rainwater harvesting. This is something that we need to take seriously as a nation. It's been done in Australia. We need, like John said, things like legislative drivers and whole regulatory regime and stuff like that. But ultimately, it can develop into an industry, in my view. So that's part of what I wanted to share on that front. Yeah.
Yeah. Thank you very much, Bob. And in fact, it's interesting that the images you showed, and indeed, on the guide project, the only area we could find substantial land for stormwater storage is in the Gayak area. So we are building two massive ponds there, upstream to hold large volumes of water that would have come downstream to cause flooding in the inner city. Right. So we need to be wrapping up because of the time of for our UK colleagues. All right. So there's a comment here. Let me just read a few of the comments and then we can take closing remarks from Bob and close the session. Okay. Okay. Let me see. Sorry. Let me just look at. So, Eugenia, personally, I've learned that being in power isn't the only major way to make a positive change in Ghana. Today's presentation has changed my mentality, especially as a development studies student. A wonderful presentation. So, thank you, Bob, for that. Changing some minds here. There is also another. This is from. Okay, so Lazy wanted the let me just say that if there is a Flex Connect platform where we share the presentation, the video recording, and also the PowerPoint presentation. So I'm sure I'll put a link there, or maybe next time when I circulate this message, I'll put a link there, and then those who wish to connect there can connect and get the next information. Okay, Sam, thank you, Prof, for your presentation. Going back to, sorry, what's going on here? This is from some, it says, thank you, Prof, for your presentation. Going back to the Odo River dredging, could you share some of the things people can do in their homes or on their building project to minimize the volume of surface water runoff to our drainage systems in order to reduce downstream flooding? Okay, so I think Prof has shared some of them. Some of them, rainwater harvesting,
don't pave the entire compound.
Yeah. So the landscaping of our
landscaping.
Yeah. We have a law, building regulations require that people leave 20% of the land space to allow for filtration, but people don't do it, and the enforcement is an issue. So really and truly, the biggest issue we have is the development control. Where permits are being granted for people to build in
Prof,
wetlands and all.
how does one operate the single lane two pipe line system in segregation of waste and flood water?
Prof, did you get the question?
Yeah, I didn't quite get the question, but it's talk about the pipe system that I presented. Are you talking about for an existing system that already has a sewer or a new system altogether?
I mean, the existing one, please.
Yeah, the existing one, like I said, where instead of having to construct a separate stormwater pipe network, you can integrate it into. I showed the video that showed how you can retrofit the system onto existing. So your existing system becomes your power sewer, and then the new system, which you can use no-dig techniques to connect. So you build around the existing manhole to get your storm chamber, and then you can connect through no-dig techniques to get your stormwater network.
Thank you very much, Paul.
Okay, so I'm sure you can engage.
You can connect with me offline. I mean, for further details, because this was just a sort of high-level preliminary sort of. There are more details that we can share, and there are papers and stuff that in terms of the work that the guys done and such.
Yeah,
we can share with.
Yeah, excellent. Thank you. So you can link up with Prof on LinkedIn as well. And Prof is on the First Connect platform, so you can directly send you messages as well and respond. Finally, from J. Hilford, I don't know if it's my own Joseph. I think so. Wonderful, workable ideas expressed. There are willing, capable, and trainable young persons around to carry the vision of redemption for this generation. Unfortunately, the government does not seem to be ready to take on what non-partisan citizens are ready to offer. How do we break through this barrier, Prof?
It will take all of us collectively. It's taken all of us collectively, so we need to have the right leadership in place. And we as a people also have to be. That's why I ended up on that Chronicles 2, 7:14. We all need to turn from our wicked ways collectively as a people. That's when then the Lord will hear and heal our land. Until we do that, change our mindset, change the way we approach problems as a nation, all of us. Then, so that's the message from the Almighty for us, in my view, because I've been asking this question, and that's a quotation that kept coming through loud and clear. And that's why I ended up showing what's the Ivory Coast situation. We collectively, it's not just the government, or it's us as individuals. Because who's doing the galamsey? Isn't that Ghanaians? And then using foreigners as well to, and it's because our taboos and norms in the past, in the ancient past, when you farmed, you had to leave a buffer strip, and then you go to farm only on certain days. It was all part of conservation of resources, and there's a season for hunting, season for snails, season for this. We've put in all that, say it's all a cake and whatever, So we need Sankofa big time. But the Sankofa needs to be brought into modern times, reinterpreted into modern. So it's all of us.
All right. So let's wrap up. Yes. Thank you very much, Prof. Okay.
Yes. Can I make a comment?
Please go ahead.
I know you want to close. I know it's getting late and it's late for me now. But Prof just made. You see, John, we are having these lectures. Unfortunately, I'm not able to take advantage of it. Or happens after listening to something like this. What do we do with the information that we get? Is there any follow-up? Because collectively, we cannot do much unless there's somebody to want to.
Hello, are you there?
When you say somebody, you mean somebody with power or authority, or somebody
on making sure that something is done apart from what government is doing. You're talking about the law that when you build 20% should be left for whatever. Is there anybody making sure that people who build, even if not individually, those who build as a profession, those who build and sell the estates and the place that we have, is there anybody making sure?
Well, it's all to do with standards. So that's where role of institutions,
civil society or anything. But most importantly, for us, what we can do from such lectures. John, is there any idea of any kind of follow-up after we've listened to such rich research, such rich information that we get? What do we do with information? What happens after that? Is it just listen, go and sleep and prepare for the next one?
That's a very good question.
I'm just thinking aloud here. And I think I'm calling for the chronicle that he's talking about.
Exactly. And that's what Bob is drawing attention to, that this is something for all of us. So perhaps my response, my role here is to bring people together and get them information. Maybe we need someone to drive the advocacy aspect of things, that when we have received this, maybe a couple of papers, to a couple of newspaper articles or whatever to push the ideas. So I think you are right. We need to perhaps look at what next, or maybe we have to ask ourselves, and so what? We have received this information, and so what? What do we do with it? And perhaps that is something that maybe, if I know you are very good with advocacy, you're a very good writer. So maybe if it's something that you don't mind taking up, but you are very, very right. Apart from what we receive and every individual goes away, some might do something with it, others nothing. And mostly our subjects are more about self-development, but today we have more focus on development as a country, and that brings this matter very it makes it very pointed that something has to happen beyond the lecture. You're right. I agree. Yeah.
I mean, for example, I
So
saw about 40. Sorry,
the
I saw
challenge
about 40 something people who joined in. Now it's 20 something. But maybe we could say collect data or put information together as to people who listen to such lectures and see, even if you want to take things ahead, who do you do it with? Maybe we could prompt people to say, those who are interested to carry this forward after the lecture, put your name forward down, and somebody may be able to lead such a. I mean, I think what I'm saying is, what do we do with the information? What do we do? What we listen to? What we hear? I mean, we cannot leave it all to the government or to partisan situations.
Yeah. Yeah, you're right.
In making sure that things happen.
Yeah. Okay, so let's wrap up. I mean, we I don't know, because of the time change. I don't know if 8 p.m. start is too late for UK. Whether we should do 6 GMT, and then that will be 7 BST. Matthew, what's your thoughts before we wrap up quickly? So we know next session what we do. Is the 8 BST okay? 7
Earlier the better for me.
I mean, I'm
Okay.
currently in the UK, but if it's important for me, I don't know, I don't mind what time, but maybe, John, I don't know if you do it, but do you have a database of people who have been listening to such talks that you can do a survey, see all that?
It's a mixed, platform actually. So I'll put a link there for, we have a platform where we put the materials shared. So I'll put a link for those. Yeah, so we have quite a number on that platform. We could have
polling.
Yeah, I see. But last month we had attendance, and this month too, just maybe because it delayed a bit. So, but it's fine. Let's wrap up. All of this is very, so let's wrap up, and then before Bob gives the closing remarks, I just want to announce the next session. The next session of Let's Connect will be on the 26th of May, and it's going to be on the power of networking on the 26th of May, and it will be on the power of networking. So please take note. That will be the next session of Let's Connect. Let's Connect. So, all right, Bob, please, if you can give us your closing remarks, so we can close the session today.
Thanks for closing remarks. What I'll say is a big thank you to all of you who joined in today's session. I'd invite you, I mean, those who have a water bias, the next major event for me is going to be Water Africa, which is coming on in June, and end of June, from June 26th to 28th, where we're going to have a number of exhibitors coming from different parts of the world to showcase their technologies. And then there'll be a number of seminars, both on the water side and also building and construction. And then on the third day, I'll run a workshop. I usually run these workshops as part of the Water Africa event. In the past, most of my workshops have focused on issues to do with flooding. But I think this time around, I want to do with technology development, intellectual property, patents, trademarks, raising our consciousness in that sort of area. So I'll post that on the platform, I think, and yeah, I'd say that let's all put our hands to the pump. We all have different skill sets that we bring to bear. You know, when we were coming onto the planet, the good Lord whispered into our ears that you are very special. Everybody is very special. Everybody's fingerprint is different from the other. So really what we should be doing in terms of mindset is that we're not in competition with each other. Nobody can compete with you. You got to think about yourself in terms of bringing out the best version of you onto the planet. You have a special role you got to fulfill and play. So this thing about looking at others and competing with others, and it's all bullshit in my view. We've got to bring out the best version of us. Everybody has a unique role that they have to play. And in fact, Africa itself has a unique role that it's got to play on the globe. And if you'd allow me to digress a little bit or get into this, I see that there are 3 legs or 3 strands in the world. One I call materials, the other is spirituals, and the other is humanos. And just to give you an example, materials is technological development, which is the Western world, which they have developed out of balance in terms of spirituals and humanos. Africa's role, the Eastern world has been spirituals, and they are now starting to go materials. Africa has to bring humanity to bear.
Thermodynamic.
Care for our fellow man. We are each other's brother's keeper. If we really truly care, we will not be doing some of the things that we're doing. So as a mindset change, let's go by what the Bible says in terms of what's the greatest law. Love God above all else, love your fellow man as yourself. And that's the point on which I'll end. Thank you all for being part of this.
Thank you very much, Bob. Truly appreciate today's session. It's different. It's really challenging. It's making us all ask ourselves, very important questions. And then that's what this is all about. That's what it's all about. So there's very little, like the song writer said, that's brighten the corner where you are. So all of us who have received this message, until we have someone to lead us on our advocacy front to see what we can do out there together, let's as individuals brighten the corner where we are. And I'm sure we can make little impact in our own little corners to help, drive the agenda of change and development in our country and on our continent. Thank you very much once again, Bob. And I thank all of you for joining and for your patience. We've gone beyond 2 hours, but you've been patient to you've stayed on. We had almost 50 at some point. Some have, but I have to say that the internet hasn't been great today. So I'm sure some got frustrated, by the in and out and had to drop off. And I hope the internet didn't affect the recording. So the recording will be shared on the Flex Connect platform. And the materials I received from Bob will also be shared on the platform. So once again, thank you very much for staying on, for being part of today's session. And we look forward to having you again next month on the 26th of May, discussing the topic of the power of networking. I wish you all a very blessed week, very fruitful
John,
and productive.
one final word from me is that we need to celebrate our heroes. Why do I say this? Recently, there's this guy, Dr. Thomas Mensah, he passed. He's a hero because if it wasn't for him, fiber networks would not be where it is globally. But what do we do as a nation to celebrate people like him? We need to celebrate our heroes, and that's what the younger generation will look and see, that this one has done it also before. I can also do it. Anyway, thank you so much, buddy. Good evening.
Thank you very much, Bob.
Right.
God bless you. God bless everyone. Have a blessed week. Bye.
Bye-bye, and thank you very much.
Thank you, everybody.
Bye.
Right. Bye.
Yes.
Excellent presentation. Thank you.
Thank you, Bob.
Yeah, Mr. Akwe.